Gail, today we are going to talk a little bit more about the multiplication rule, um, and we are going to talk about a piece of an updated multiplication rule, which is conditional probability. So when we talked about the multiplication rule in the first lesson of this unit, we had something that looked like this. The probability of event A and B happening was the probability that A happens times the probability that B happens. And that was okay if we had independent events. That means the probability of event B happening is not going to be changed or affected in any way because event A has already happened. But we don't always have independent events. Sometimes we have dependent events. And so we need this thing called a conditional probability that tells us about the probability that event or of event B happening given event A already happened. So we get this conditional probability when we have dependent events, and the probability of the second event happening is going to change because if the first event already happened. So this line here means the word given. So this reads the probability of event B given event A. And we have the probability that they both happen, probability of A and B, which is something we calculated in our first lesson. And then we have this individual probability of event A happening. And so, as usual, it's best to show this in practice. So I'm going to rewrite that formula here so we can use it. And so one thing you could do is use the formula if we want to assign different or more representative letters to the events in our specific problem. We can just decide is that letter or is that event A or event B, and then plug that letter in so we can sort of stay organized. So here we have students who live on campus. I believe we did this in the previous lesson. Some live on campus, some have a meal program on campus, and then some do both. And that do both thing meant that these things are not mutually exclusive. So we want to know if we're sitting in a campus facility, dining facility, which means we must have a meal program already. So we're sort of setting a condition. We know that whoever this person is that we are meeting at this dining facility must have a meal program, otherwise they wouldn't be there. We want to know the probability that they also live on campus given the information in the problem. So we're going to use R for somebody who lives in a residence hall, and we'll use M for someone who has a meal program. And so we want to know the probability that our person lives in a residence hall given that they're sitting in a dining hall that requires a meal program. And so if we use our formula, we'll replace A with M and B with R. So we need the probability that this person lives on campus and has a meal program. Well, we know what that is. That's this 42%. So 0.42. And we're going to divide by that the probability that any random person on campus participates in a meal program. So we also have that value 0.62. And so when we divide that out, I'm going to round to 4 decimal places. We get a probability of 0.6774. So almost a 68% chance that this person we're talking to, who definitely has a meal program because they're in the dining hall, also lives on campus. I'm going to minimize this so we can see it. As always, these are on Canvas, so if you want to be able to bounce around a little bit and see the document, you can. So here we have some students in elementary school, and they were asked, what's the most important goal or thing for you to take away from school? Is it to have good grades, be popular, or be good in sports? And so we asked some boys and some girls, and they did a stratified sample, making sure they asked students from different areas. And so the results are in this table down here. We want to know, what is the probability if we are randomly selecting a student, we know that that student is a girl, so we sent all the boys away and we're just randomly selecting a girl. We want to know the probability that that student's goal is to be good at sports. So we want to know the probability that their goal is to be good at sports, given that they are a girl. And so there's a couple ways to do this. Since we have a table, there's an alternate method, but let's use the method from above. We need the probability that they are a girl. And you could use letters here. And sports is the most important thing. And we're going to divide by that the probability that we would select a girl out of the whole group. So our girls that are most interested in sports are here. There's 30 of them out of a total of 478 students. So that's our numerator. That's our probability of selecting a girl who also likes sports. And then we have 251 girls out of our total number of students. And so we can simplify that fraction if we want to here. The 478s cancel. And we get a probability of 1195. So if we were to just randomly select a girl, the probability that that girl was most interested in sports at school is 0.1195. So about a 12% chance that that girl is most interested in sports. So we can use the formula. Another thing that we could do is, our condition is that we are only selecting from the girls. So if we highlight the girls row and just isolate that, sort of set this condition, we're just going to deal now with this group. So it's kind of like we've kicked all the other people out. I have 251 people. So that's my denominator of my probability. And 30 of them are interested mostly in sports. And you can see we get the same fraction, which gets us the same answer. So if we're not given a table, obviously we can't do that. But if we're given a table, we can use that method, or we can use the formula method. You know, if for some reason we don't remember that we can do that, this formula will work every time. We found the girls that also like sports, divide by the total number of students. There are a total number of 251 girls divided by the whole number of students, and we can still get our probability. So we can use conditional probability to determine if two things are independent of each other. Sometimes it's pretty clear that two things are independent. So rolling a die and flipping a coin are two independent things. Getting a 6 on a 6-sided die does not change the probability that I flip a coin and get tails. But sometimes those things are not so clear, and we can use conditional probability to decide if those things are independent. And just a couple notes here about being disjoint and being independent. You can be one or the other, but you cannot be both. And it is possible to be neither of those two things, meaning the two events have some overlap and they are not independent from each other. So let's look at an example where we determine independence. We're back to our same problem here about living on campus and eating on campus. I'm going to address this first. Are they disjoint? Well, we did use this example in the last lesson, and there was an overlap of 42% who did both. And so therefore, they are not disjoint because they can happen at the same time. The independence takes a little bit more thought. So we found the probability earlier of living on campus and given you had a meal program. And then we have the probability on its own of living on campus. So 56% of the students lived on campus. And so if these two events were independent of each other, these two probabilities would be equal or at least really close to each other. They are not. 0.6774 and 0.56 are not equal, and they are not close to each other. If you think about this in terms of grades on a test, a 56 and a 68 are very different. One is an F and one is a D+. So they're not very close. They are definitely not equal. And so that means that there is some relationship between living on campus and having a meal program. And this relationship means that these two things are not independent. So they are not independent because they're not equal. This conditional probability changes or this probability of living on campus changes when we add that condition that the person has a meal program. Let's analyze our children and their interests. So I believe we did something like this a long time ago at the beginning of the year, where we actually did look at conditional probabilities like we did a minute or two ago. We want to know, are these disjoint, having good grades, and gender? Well, there's some overlap between having good grades and having good grades being your interest in being a boy, having good grades being your interest in being a girl. There's overlap there, so they are not disjoint. Let's look at the independence. So let's first find the probability that grades was your thing of interest. So 247 students out of the 478 said grades was the most important thing, which gives us a probability of 0.5167. So if we were to just randomly select a student from the whole group, there's over a 50% chance that that person was mostly interested in grades. We can then go look at conditional probabilities. What happens to the probability that grades is most important when we set the condition that you're a boy? So that is, if we look at this column, 117 boys out of the 247, which is 0.5154. We'll take it one step further and find the probability that grades was most important given that you are a girl. So we'll look at both. There are 130 girls in that column out of the 247, which is 0.5179. Oops, I think I did this backwards when I was explaining. Sorry. If we're setting the condition of boys, we're looking at 117 out of 227. My calculation is still correct because I copied it off of my previous work. When I set my condition of being a girl, 130 out of 251 said grades was most important. And so what we end up with here, and please do ask if you need some clarification after that mistake. I apologize. What happens here is all three of these probabilities are close to 0.52. They're not exactly the same, but they're very close. If we rounded to 2 decimal places, we would round them all to 0.52. So that means your gender has not really influencing the likelihood that grades is more important to you than being popular or being good at sports. And so these are independent of each other. So gender and your goal are independent of each other. So as always, if you have questions before the practice, please do ask. I'd be happy to help. If you have questions while you're working through the plastic practice, please do ask. I highly recommend you doing these on paper or in a notebook before you enter your answers and ask to talk about them and see if you're right before you put the answers in. Take your time on these and good luck.